Hey guys, welcome back to my second part of simplifying surds. So, in the previous video, I gave two examples and a brief introduction of what surds are and, the actual definition of them. So, in this video, we're going to consider another case where you have a surd and you can add another surd, and we want to know, what the hell does it actually give? What can it provide us? Well, thankfully, this shouldn't be too difficult, okay? But the one thing to know, when you're adding two surds, you cannot just, combine surds into one surd. The only time you combine surds if they have the same number inside the root. So if you had, for example, 2 root 3 plus 5 root 3, notice that you got the same root. So you have root 3 and root 3. So therefore, you can just think of it as 2 plus 5 is 7. So the solution would be 7 root 3. A good way to notice is that this is like saying 2x plus 5x. We know straight away that because they both have x's, we can add up the terms. So it'd be 2 plus 5 is 7, so 7x. So yeah, it's actually the same thing. You just treat root 3 as x's. However, if you had two different surds, for example, 5 here, then this is like saying, let me show you. You had, for example, 5 root 5 now. This would be it. You can't do anything further because we have different surds. So this would be our simplified surd. It's the same as saying 2x plus 5y. We cannot simplify that, can we? This is the end of the equation. Good. So that's really simply all you have to do about plussing surds. I mean, it works the same if you were subtracting. If I stuck a minus sign here and a minus sign here, it's the same procedure. No difference at all. Well, let's do a quick example then, yeah? So, example 1. Now, suppose we had root 50 plus well, let's just do root 40 again, like the previous one. Root 50 plus root 40. Now, how do we solve this? First things first, we have to simplify the surds, and we got to break them up. So root 50, we can say we need at least a square number inside, two numbers, and one of them should be a square. We said previously that we can use 2 and 25. Okay, so let's just say 25 times 2. Now, next one, in this one, we have root 40. And previously, we said we can use 4 and 10. 4 times 10. Because we've got plus there, we just smash out a plus. So, what do we have here? Square root 25 times 2. Again, we can do it separately by the law of times table. Times root 2. I'll just change the color of the plus to red so it doesn't mix up. Plus. Now we have square root 4. Oops. I don't like too many changes in color. Square root of 4 times square root 10. Okay. These are square numbers. This is 5 and this is 2. So we're going to have 5. We can stick it on root 2 plus root 4 times root 10 would be 2 root 10. And this would be it. Notice that these two they're not the same bases, okay? I mean, you could break down this to root 2 and root 5, but trust me, it's not really going to help. So this would be the end of the case. Let's try one more example, yeah? Let's try one last example. Okay, and here's a second example, okay? I'm just trying to think of values that actually make sense. Okay, so what I have so far is root 75 plus root 108. Good. So this is something I have to think about carefully. Okay, so once again, same procedures, yeah? So let's just think what divides into both these numbers. It's not easy to figure out instantly, but we should try. Both these numbers, believe it or not, are in the 3 times table. There's a really cool trick to figure this out. To know that numbers are in the 3 times table, we should add up these terms. So 7 plus 5 equals 12. And we know 12, if we add up these two, 1 plus 2 is 3. And 3 is in the 3 times table, so we know it's in 3. This is just a trick I learned in uni. Same with 108. So we can do 1 plus 0 plus 8 is 9. And 9, like 3, is in the 3 times table. So they're both in the 3 times table. Trust me, this actually works. And don't try this for 4 or 5 because it doesn't work like that. Not that I know of. Okay. So now we know that this is these are both divided into 3. What does do they go into then? 3 times what makes 75? 3 times what makes 108? So our calculator, well, we can just do 75 divided by 3. It's 25. How convenient. So we can say 3 times 25 replaces the root 75 plus, again, I like my red. Once again, so 108 divided by 3, 36. Yep, obviously, guys, this ain't a coincidence. You know, I actually chose these values. Anyway, once again, using the law we just learned, splitting these terms up, we have root 3 and root 25. Root 25 is 5, so we have 5 root 3. Okay, plus, same thing, 36 is square, so we have 6 root 3. Whole number 6 times root 3, 6 root 3. And because they both have the same base, like we said in the beginning, you can plus these two terms. So 5 plus 6, 11. The solution would be 11 root 3. And that's it, folks. All done and dusted, okay? So this is a cool trick, you know, how to know your 3 times tables. Check this in 3 times table. Otherwise, that's it. I hope you guys enjoyed the video. Hopefully I'll make more. Take care, guys.